Hi, welcome to my video on the diagonals of geometric figures. Practice 1. A rectangle has a length of 12 centimeters, an area of 60 square centimeters. Find the length of its diagonal. So the units are centimeters and centimeters, that's okay. And we have a rectangle. So let's draw a rectangle, which is a parallelogram with 4 right angles. Opposite sides are parallel, and the diagonal goes from one corner to the other, not being a side. And the length, let's call this the length is 12, and the area, and it says the area is 60. So the area of a rectangle is length times width. So if that's the length, this is the width, and this is its diagonal D. So the area is 60. The length is 12. So if 60 equals 12 times W, then divide by 12. W equals 5. So the width is 5. That means we have a length and a width. We have 3 sides of a right triangle. So C squared equals A squared plus B squared is the Pythagorean property in relation to a right triangle length of the sides. So D, which is the C represented here, so D squared is A squared, could be the length and the width squared. So it could be 12 squared plus 5 squared, or reverse, 5 squared plus 12 squared, same. So D squared is 12 squared is 144. 25 squared is 25. So D squared is 169. So D is the square root of 169. Again, this could be plus or minus, but we're only dealing with the plus. So D is square root of 169 is 13. So the diagonal has a length of 13 centimeters. Number 2, a rectangular box has dimensions of 6 feet, 8 feet, 24 feet. Find the length of its diagonal. So a rectangular box is like this. So we draw, so let's draw the box like this. Drop this down here. So there's a rough sketch of the rectangular box, and it's a 6 by 8 by 24. And it really doesn't make any difference where you put these, they'll all work out in the end. So let's go 6 and 8 and 24 is the height. So let's draw the dimensions in here, or the edges in here that you can't see. So now we got a rectangular box, and we want to find the length of the diagonal. Well, the length of the diagonal of a rectangular box can go from this corner to this corner, or it can go from this corner down through here to this corner, or from here down to here, or from here down to here. So let's call this A, B, C, and D. Let's look at these corners. So the diagonal of the box is the segment going from A to D. That's the diagonal of the box. But to get the length of that diagonal, we have a diagonal that's on the bottom of the bottom is A, B, C. There's the bottom. A, B, C, F is the bottom. So if I draw a diagonal of the bottom, so that's AC. I have a right angle here at A, B, C is a right angle. So if I take that triangle and put it right here, like this. So if I label it A, B, C is the triangle. There's the right angle in the corner of the box. And this side is 6, and this side is 8. So we'll get AC. AC is the length of the diagonal in the bottom. So when we get the length of this diagonal, now we have another right triangle, ADC, with a right angle here at ACD will be a right angle right here. And so once we get the length of this side, And we have this one, we use the Pythagorean again to get the length of the diagonal. So we have c squared is a squared plus b squared. So x is the hypotenuse of the right triangle opposite the right angle. So that's c. We have a 6 squared and an 8 squared. So x squared is 36 plus 64. X squared, when you add them up, you get 100. And x is the square root of 100. Square root of 100 is 10. So what we have is 10. So this is 10 right here. Now, that means we have another triangle. And let's draw this triangle this way. Like this. And we'll label that as A, C, D. And the right angle is that A, C, D. There's the right angle right there. Right in that corner. So we have DC is 24. We just found X, so that means that AC is 10. So AC is 10 because that's what we let X be. So that means we're going to find the length of the diagonal. Let's put this as the diagonal of the box, D. AD is the diagonal. So therefore we have, again, C squared is A squared plus B squared. The diagonal is D, so C is the hypotenuse, and this C squared is A squared plus B squared. A and B are the legs. C is the hypotenuse opposite the right angle, so that's the D. We have a 10 squared, and we have a 24 squared. So D squared is, 10 squared is 100. 24 squared, 24 times 24 is 576. And when you add them up, you get 676. So D is the square root of 676, which is 26. So the length of the diagonal of the box, D, is equal to 26 feet. So I had to get the diagonal at the bottom with Pythagorean and then work out the, because I have two right triangles, do the Pythagorean property twice. And number 3, the base of a right cylinder has a circumference of 125.68 millimeters. The diagonal of this right cylinder is 50 millimeters. Again, they're all in the same unit, so that's okay. Find its lateral area. Well, let's draw a right cylinder. Here we go. Draw this around. That's the bottom of the cylinder is a circle. So there's the top. There's another circle. So the base of a right cylinder, the base has a circumference of 125.68. The diagonal. Now in a right cylinder, you have to go from the top to the bottom, but you can't come down here. You have to go through the middle. So a diagonal normally goes through the middle of whatever figure you have. So if you join this up, and there's the middle of the cylinder, so that's the diagonal, D. And this is the height of the cylinder. And now we have to look at, that's the radius right there, that's R. So let's see what information. So we have a diagonal is 50. Find the lateral area. Well, let's look at the lateral area. So the lateral area of a box, what do we need? The lateral area, LA, is in a cylinder. The lateral area is made up of the area of, we have two bases, which are circles, so it's made of the side. Remember what I did previous to this? I took the cylinder and I cut it. I cut it down through this edge, so that was the height. And this, when I unrolled it, this distance right here that I'm marking in dark is the circumference. So when I cut this down and roll it out, then this is the circumference. This right here is this distance here, which is 2 pi r. So the lateral area is the length times the width, and the length is 2 pi r h, 2 pi r circumference, and the width is the height. So that's the lateral area. So I have a 2, I have 3.14, but I don't have my radius. I have the height is, I forgot to put the diagonal is 50, so we get that after. So I don't have my radius and I don't have my height. So let's see, here we go. So why did they give me circumference? Circumference is 125.68. So that means that 2 pi r equals 125.68. So 2 times 3.14 times r is 125.68. So that's 6.28 times r is 125.68. If you take a calculator and divide that out, you will get a 20. So 125.68 divided by 6.28 is 20. So the radius is 20. Now, if the radius is 20, and we got the diagonal is 50, so if that's 20, then we go all the way across, we get 20 and 20, so that's a 40 for the diameter of the circle. So that means we have a right triangle, and let's draw that triangle. So we have a 50 for the diameter, the diagonal of the cylinder, and we have a 40 for the diameter with a right angle. So there's the right angle. There's 50 and 40. So we need the height of h. So c squared is a squared plus b squared. So 50 is, c is the length of the hypotenuse opposite the right angle. 50 squared is 40 squared plus h squared. Oh, that's a 2. So that's 2,500. 1,600 plus h squared. So 2,500 minus 1,600 is equal to h squared. So h squared is 900. So h is the square root of 900. So h is equal to 30. So we have a height of 30. So now we have a radius of 20, which goes here. We have a height of 30, which goes here. And so when you multiply all that out, 2 times 3.14 times 20 times 30, it comes out to be 3768. And that's in millimeters, so that's square millimeters it comes out to the nearest unit. So that's the lateral area of that cylinder. So what happens is, again, notice the info used. You did you had to use the circumference to get the radius, and you had to use then you had to use the Pythagorean property to find the missing side of a right triangle, and then you had to know the formula for lateral area to work it out. And again, it's circumference. The lateral area is just, if you put that there, is, you could say the lateral area is circumference times the height, and which is 2 pi rh. And that brings us to the end of this video. And again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.